Hello, good morning, dear friends, my dear students, fourth semester electrical engineering and electronics and telecommunication engineering. Till now, we have seen lot of videos, notes, and we have also taken the various classes on almost all of the units. Now, in this video, I am going to present you the numericals on the feedback amplifiers, which is unit number 4 of your syllabus. Myself here, Lalit Kumar P. Bhaiya, Associate Professor, Electronics and Telecommunication Engineering Department. Today, we will go through these numericals of this feedback amplifier. So I have taken the numerical from one of the standard book, and from which we will go one or two standard numericals of these feedback amplifiers. You are already known about the feedback amplifier, that is feedback amplifiers are used because on these properties we will see the numericals of the feedback amplifier. Feedback amplifier desensitize the gain, reduce the nonlinear distortions, reduces the effect of noise, control the input and output impedance. The numerical which we are going to see, we will see how the input impedance increases and output impedance decreases. We have to calculate this, and we have to also calculate the gain, how this gain reduces or desensitize. Similarly, the increase in the bandwidth due to the negative feedback, that we have already seen in the theory period as well as in the videos, last videos. And this is the structure of the feedback amplifier. The open loop amplifier, feedback circuit, load, and this is source. And feedback amplifier uses the negative feedback. So this negative XS minus this XF shows the negative feedback amplifier. Or you rather way you can say that the amplifiers are always uses the negative feedback mostly, and oscillator uses the positive feedback. So this is about what we have already taught. This I have shown you. Now let us go for the numerical. Here I have taken this numerical. You can see this is numerical 2.3 shown here, and numerical is for the circuit shown in figure below. Calculate this AVF, voltage gain with feedback, input impedance with feedback RIF, and output impedance with feedback. And here it is written transistor parameters. These are HIE is equal to 1 kilo ohm, HFE is equal to 100, HRE is equal to 0. Since these parameters are given in emitter form, so this is a common emitter configuration. Both the transistors shown here, a common emitter, and this is also common emitter. And the feedback is also provided here. You can see from 1 kilo ohm, this second stage emitter, through this 100 kilo ohm, the input of the first stage, that is base. So feedback is provided. We have to identify which type of feedback is associated with this circuit, and how we can calculate the overall voltage gain, overall input impedance, that is input impedance with feedback, output impedance with feedback, and voltage gain with feedback. Let us go step by step and see the solution of this circuit. Let us first identify the topology of the feedback. Which type of topology is in this feedback? Since V0 is equal to 0, does not make feedback 0, but I0 is equal to 0, output current is equal to 0, makes the feedback to become 0, and hence it is a current sampling. Since output current is 0, makes the feedback 0, therefore it shows a current sampling, and this feedback is fed in shunt with the input signal. Hence, the topology is current feedback. So you can see this equivalent diagram. From this output we have taken the input here. This is fed in shunt, therefore this is a shunt. Since output current is 0 and the feedback is taken in terms of a current, so this is current shunt topology or current shunt feedback. Now step 2, what we will do here, step 2 and step 3, find the input and output circuit. So this, you can see this circuit, we can find the input and output. We have taken here this feedback and connected 10 kilo ohm resistance over here, and this we got the input circuit. While at the input, this 1 kilo ohm is parallel along with the 10 kilo ohm in emitter resistance. You can go back and see this diagram. So this is 1 kilo ohm and this is 1 kilo ohm and this is 10 kilo ohm resistance. These two resistance will come in parallel here. Similarly, 1 kilo ohm and this 10 kilo ohm will come in parallel over here. So this is the equivalent circuit you have to draw here. 1 kilo ohm and 10 kilo ohm in series at the input and this parallel at the emitter side of the second stage. So this is the equivalent diagram. This is common emitter, this is also common emitter. CE followed by CE with feedback. So feedback, after removing this feedback, after taking the effect of the feedback, we have drawn this circuit, and later on in step 4, replace the transistor with a H parameter equivalent. So dear friends, dear students, you can observe here, this is the H parameter equivalent of the first transistor and this is the H parameter equivalent of the second transistor. These two transistors are shown here. These are the two parallel resistances. You can see 1 kilo ohm, 10 kilo ohm at the emitter to ground, these two parallel, and here these two series resistances at the base of the first stage is connected, and 1 kilo ohm resistance already is in series with the source. So this is converted into the current source, IS parallel to 1K, where in actual circuit it was Vs in series with the 1K. So this parallel connection is the Norton equivalent connected here. This series combination, this is the transistor model here, and this is the 2.2 kilo ohm collector resistance of the first stage. This is the transistor model of the second stage, and this is the parallel connection resistance connected at the emitter 2, and this is finally load connected up 2.2, that is RC2. So this model you can easily draw, that already we have seen in the low frequency H parameter model, and associated resistance we have connected here. Later on we calculate the overall current gain. Actually overall current gain means to calculate the output current. Here you can see from this output current to the input current. But since stages are there, we have to calculate this output current divided by this input current, then this input current divided by this output current, then this output current divided by this input current. So overall we will get this divided by this. So we split this total output current. You can observe here, this is IC2 upon this is IBS. So this minus IC by IC by this IB1 minus IC by IB1. This minus I by IC1 can be calculated as this minus I0. You can see this diagram. This minus I0 divided by minus IB2. This IB2 divided by this IB1, and this IB1 is divided by IS. So we will get overall this IC2 divided by IS. The overall gain can be split into these two stages. So this can be calculated as overall gain. Next we will see this calculation. We will calculate here this output current upon IB2, first stage output current upon IB2. This is the second stage transistor, and already this parameter is given, that is HFE, is the forward current gain. This is equal to 100. Then we calculate this combination IC1 by IB1 and IB2 by IC1, and this is given by the formula minus HFE into RC1 upon RC1 plus RI2, because this IB2 upon IC1 is equal to RC1 upon RC1 plus Ri2. This can be calculated from the circuit. So here, this is the formula given from the H parameter model. Ri2 is equal to this HIE plus 1 plus HFE, which is 1K parallel to 10K. So this value comes to be 92.818, and then IV2 by IV1 can be calculated minus 2.315. And lastly, this IB1 by IS, that is the source current, can be calculated according to formula, and this is overall gain is 110.7. This is the feedback factor beta, and this feedback factor is across RE2 upon RE2 plus R dash. You can calculate this value is very less than 1.09. And finally, you can calculate D factor 1 plus A beta, negative feedback. So 1 plus A beta, this factor is 11.063. And lastly, you calculate AIF, that is A upon 1 plus A beta. A, where this is the open loop gain. This is already calculated above 100, this one 110.7, and 1 plus A beta we have calculated as a D factor, that is 11.063. This is called as return factor 10. Now this overall current gain is 10. Overall input impedance is given by this formula. Simply you can see the circuit and calculate this one, 1K parallel to 10K plus 1K, and parallel to this RI1, that is HIE. So this value calculated. Then input impedance with feedback, that is Ri upon D. So you can calculate in current shunt feedback Ri upon D. This is 43.20. Input impedance in current shunt feedback, it is very less. RO is infinite. ROF with D factor HOE is equal to 0. RO dash is 2.0. And finally, the effective output impedance with feedback comes to be 2.2 kilo ohm. So dear friend, please you go through this problem. This type of various problems are there. You can go through it and try to calculate the value. I have also considered this circuit. In next video, we will go through this problem. One more problem. Thank you very much. Thank you very much.